So you are here to hear me talk about Graviton instances and our migration to ARM. For those who probably aren't aware, I feel like I'm talking to a crowd who here has used Graviton instances? Okay, that's most of you. So I'm just going to skip through this really, really quickly. For those that haven't and are like, what's this Graviton thing? I've used ARM. I've got like a new MacBook. Amazon released Graviton instances quite a while ago, 2018, the first Graviton instances, the A1 instances. At the time, really fantastic. It was the very first, what I would call a business offering for ARM, right? This is several years before Apple adopted the M1 Macs. At this point, really, ARM instances were Raspberry Pis. Like, the closest you got to a server was, hey, I'm really bored. I've got a bunch of Raspberry Pis. What if I make it into a Kubernetes cluster, right? Because that's the new thing. We don't care about running Linux on everything now. Now it's like, what can you put Kubernetes on? That said, the next year, I think this was the biggest change. Graviton 2 instances came around in 2019 at reInvent. They were announced. This is the first time that we got EC2 instances that really matched the existing instances that we had, right? Before it was like, cool, I'm running, an M5. What does that equate to with an A1? Well, it's apples to oranges. So the cool thing was, 2019, this all changed. We actually got instances that matched, and so now it's like, oh, cool, I'm running an M instance or an R instance, and like I could start to compare. That expanded out to burstable instances about 18 months later. This was from earlier this year. The C7G instance came online using Graviton 3, which was also featured in the keynote, where Adam announced a bunch more other instances, including C7GN, which brand new, and I'm excited about, and I'll talk about that a bit later. But overall, what are we talking about? Basically, Graviton and ARM. The whole point of this is better performance for less cost, right? And then if you're into the whole green energy thing, right, this uses way less energy, which means that on Amazon's side for those data centers, it's a whole lot less cost for them, and it's better for the environment. Again, if you watch the keynote, Adam talked about a bunch of this stuff. So all that said, Graviton's pretty cool. Who am I really briefly? I'm Jason. I work at Datadog. I'm not going to give you any of the Datadog ad stuff, but my contact info's here on LinkedIn. I'm Get Bisect. My email's up there. If at any point you have a question and I don't get to answer it during this session, or if you go home and you're like, I have a question about something, feel free to reach out to me. I am always available. Also, for folks watching on video, feel free to reach out as well. I'm Get Bisect nearly everywhere. LinkedIn, as mentioned. Twitter, I just kind of deleted that because of the whole trash fire there. Also Pokemon Go, so if you still play, we can be friends. Datadog, a little bit about Datadog. Again, not going to do the whole spiel, but we are a monitoring and security platform, right? This means that we do metrics, APM, distributed tracing, logging, real user monitoring, synthetics monitoring. On the security side, we do Cloud SIEM, application security monitoring, a whole bunch of stuff. I'm not a security guy, so we do a lot of stuff that I just know very little about, and people tell me that I should do things to be more secure. Say, good, I will go do them, and hopefully that's good enough. The nice thing about Datadog, though, is it puts everything into a single pane of glass. And that means everything, right? So whatever you're running on Amazon, all of those managed services, all of your EC2 instances, any of your Fargate-related things or serverless-related things, if you're running in a mixed environment or multi-cloud, getting that all into one place is important. And so our biggest thing at Datadog has been that you should monitor everything, right? You always encounter that. You have an issue, and you're like, oh, we didn't have a metric for that, or we didn't have information about that incident, and now we can't go and resolve it. So if you monitor everything, if you're bringing everything into one place, it helps you out with all of that. All that said, that is what led us to sort of our first dive into ARM, right? So back in 2017, we were running a hackathon. We run regular hackathons throughout the year with our engineers, and it's a nice opportunity for engineers to take a break, a few days outside of their regular work, and get to play around with technology and do really cool things. Hackathon projects have done everything from IoT devices to check whether the bathrooms were like full, so you didn't have to like get up and walk halfway across the building to find out that you were waiting in line, all the way to things like this. This is the puppy agent. So in 2017, 3 of our engineers, Masi, Jaime, and Greg, thought, well, what if we could get Datadog on those Raspberry Pi Kubernetes clusters, right? Because again, that's at the time all ARM was really used for, was IoT devices. So they had this hackathon project, and the idea was, let's strip everything out of the agent, as small as we can get it, while still keeping those system metrics, and see what we can monitor, right? How small can we actually get this? So they ended up proceeding with that. This was Masi's initial statement as he was trying to pitch this hackathon project to everybody, right? Let's strip it down. How small can we get it? In case you needed extra motivation, on the GitHub pitch for his hackathon, he was like, it's puppies. Like, don't you want to play with puppies? So all that said, we ended up doing it. They built this IoT little agent. It actually graduated, became a full project. So if you are doing anything with IoT, the Datadog IoT agent still exists. We upgraded it to version 7 of the agent, which was when we did the migration from Python to Go. And it's still around, so it's pretty cool. From there, it graduated, and we ended up starting to build full-fledged ARM instances, right? Once we saw that Graviton was getting more popular, obviously we want you to be able to monitor your Graviton instances, so we started releasing full-blown ARM64 agents. This meant that we actually had to have build systems in place to start building these packages. So that was sort of our first foray into this. But I would say that that's not really adopting ARM, right? At this point, it was all about supporting you, supporting our customers, anybody that was actually running ARM. So what does it look like to actually adopt and like start moving our stuff to ARM? A big part of it for us was looking at trends, right? Like the first question you have to ask when you're moving to ARM is, when do you actually adopt this, right? And so as we were looking, 2017, we're like, cool, nobody's using this for serious things. It's just mini Kubernetes clusters and IoT devices, so we're not going to move our services over. But then one of the nice things about working at Datadog is that we can see trends. We've got over 18,000 customers sending us all of their data. It's really easy for us to anonymize that and then aggregate it together and find trends. So we started doing that when we were looking at containers. This was several years ago, and we were able to see the trends of like who's using ECS, how does that compare to Kubernetes, what are people running in containers. This is a big thing for us as we were adopting containers and seeing how others were using it. We then moved into serverless. We could see all of that data, so it starts to be interesting. What are people running in serverless? What languages are they using? What's the average latency, or things like that? And then most recently, we launched a security report. So we took a look at folks' security data. This one is particularly interesting. As mentioned, I am not a security guy. If you're not a security person, I highly recommend that you read it. The first thing that it confirmed for me is that I may not be a complete idiot. Apparently, everybody else thinks IAM is super confusing. So if you're like me with that, read the report. It's got a bunch of suggestions. But all of that does lead to ARM, right? We were starting to think, well, Graviton 2 is out. It's starting to gain some traction. Let's look at what that actually looks like. So I pulled this stat from our metrics system when I was writing this talk in September. And from the introduction in 2019 of Graviton 2, again, that's where the EC2 instances started to be more in line with what we expect, till now, 25,000% increase, right, in the number of hosts that are reporting, ARM64 hosts that are reporting to Datadog, which this is huge. I don't think I've seen this adoption for really any other technology, just the rate of adoption. So that gave us a clear idea that, well, there's a lot of folks using ARM. So we're not going into completely uncharted territory. It also means that there's probably a good chance that the software and the libraries and everything else that we're using is starting to get ARM support, right? And that's a big thing when you're considering whether you should move, right? Does everything that you require, because if nothing that you require is supported on ARM, then it's kind of a dead deal. So all that said, what do we run, right? What do those libraries look like? Our systems are kind of crazy. This is an actual service diagram of Datadog internals. You probably can't read any of it. That's sort of intentional because some of it's secret, but also because it's insane. To say that we run a lot of microservices is like a crazy understatement. So all that said, though, what are we actually running with this? Like, all of this runs on Kubernetes. We don't use EKS. We actually manage our own Kubernetes control plane because we want to manage the performance and the reliability of that. Microservices, lots of different languages, right? You use microservices because you can decouple your service teams. They can use the tools that are best suited for the problems that they have. So our top 5, according to GitHub, are Python, Go, JavaScript, shell scripts, and Ruby. That said, we have a lot of stuff that's moving to Rust. We use TypeScript. We have C++. We basically, if there's a language that you can think of that would reasonably be used at a company, we probably use it. So no Fortran, like 70 or 90, but like anything else. So with all of this complexity, it means that you need to start with a plan, right? Once we decided, cool, this is a thing that we really want to do, that we really want to look into, what's that plan? So the plan really has 3 pieces. At least 3 pieces is what I consider, and that's really, you have to think about the infrastructure. Right? Again, we run on Kubernetes, so we have to start thinking, can we run a mixed node cluster, right? What happens if you add Graviton instances along with your Intel instances to your Kubernetes cluster? What does that look like? And that has a whole bunch of other things that are involved, right? Not only is it, can you just add the nodes, because Kubernetes has supported ARM64 nodes for quite a while, but you have to think about everything else involved, right? Like the containers that are running on it need a container runtime. And surprise, not all container runtimes support ARM64. So you might have those nodes available, but nothing's ever going to get scheduled to them. You also have to think about everything else that you're running. If you're running a monitoring solution like Datadog, we deploy as a daemon set, which means that one pod gets deployed to every single node. But if your daemon set doesn't support ARM64, it's not going to get deployed there, which means now you have no monitoring on those nodes or whatever you're using that daemon set for. And then similarly, things like sidecars or init containers, right? All these other things that are involved, and suddenly you realize this is a little bit more complex than just saying we're going to deploy new nodes. The second part of the plan really had to deal with build and deploy, right? CI/CD. How do we actually take the applications that we have, package them up, build them into containers, and deploy them out to the right spots, right? So the 2 parts are really that packaging things up, compiling, making sure that all your dependencies are supported on ARM64. And again, that second part, packaging things into containers. What does that build system look like? There are a few ways to do this, and there are pros and cons to each. You could build separate images for everything. You could build multi-architecture images. We ended up doing multi-architecture, and I'll dive into that in a little bit more. But basically, that means whenever we have a service, we package it into a container. It can now be deployed to both Intel and ARM64. And there's good reasons why we did that. And again, I'll cover that in a bit. And then the last bit is the actual applications and services themselves, right? As mentioned, we run a lot of different languages. And so for some of those, if you're thinking of like Python, PHP, things that are interpreted, it's relatively straightforward, right? You put that Python binary, it supports ARM64, so basically all your Python scripts are going to run. It's usually that simple. That said, It not always is, right? Like, especially when you have compiled programs. So a lot of our services are written in Go. Go dependencies then have to be compiled, so you have to see if your dependencies will compile on ARM64. And then even worse, a lot of those dependencies aren't really code per se, they're wrappers. So they link out to native libraries. And when it comes to native library, that library that exists for Linux that's running on x86 may not actually exist for ARM64. So that dependency that you have that's linking out to there, what's it going to link to now? So things get very, very complicated very, very quickly with that. So all that said, with these 3 pieces in mind, our plan, number 1, chat with AWS. This, out of any lesson, actually, should be the one that you take away. Talk to AWS. I know that sounds kind of weird sometimes as a former, like, I used to be a full-time developer, and like talking with a sales guy or my account guy, like, not something I want to do, right? But in this case, Amazon is fantastic. Not only can your account reps give you info on what you plan to do, they can connect you to the right support folks in AWS. In this case, they give us a huge deal. So worst case, you chat with your AWS account rep, they say good luck, have fun. Best case, though, you can save a ton of money. So definitely recommend that you chat with them first. Second part for us was identifying services. So as we were doing this, reminder that we're doing this because we want better performance, which means we need less compute. And then overall, we want our compute instances to cost less. So it's all about saving money. So the first thing that we did was we identified our top 25 services by spend. Where are we spending the most money? Together, all of these services were way more zeros on that bill than I can mention. It's a lot. I was chatting with my partner, who's an engineering manager, and 1 month of our spend was more than their annual spend for AWS. So you need to prioritize the things that will actually make an impact. That said, we did take a look at some of what we thought were the low-hanging fruit, things that would be easy to migrate over. And yeah, some of those we added to the list, but primarily we're focused on where could we save the most money. After that, check metrics, right? We set a baseline. How do these perform now? How many instances are we running? What does traffic look like? What does CPU and memory and network look like? All of the things that we need to get a good understanding of the health so that as we do this migration, we can ensure that we're getting the benefits. And then like anything, we work iteratively. So you start with a small project. You see if it's feasible. You do that work in staging or sandbox. You continue to measure that, and then you iterate. Once you get that into a good spot, we end up canary deploying. Not technically canary deploying. So we start off with shadow deploying, actually. So we'll dupe the traffic, send that to the small instance, see if it actually handles some real-world traffic in a reasonable manner. And then we start the canary. So then we'll actually redirect some of the traffic to these services that are on ARM64. We'll continue to ramp that up until it's fully diverted over, continue to monitor that, and should things go wrong, it means that we can always roll back to the x86 instances. And throughout all of this, we obviously check the metrics. You are operating production systems. You should have metrics on everything and keep tabs on how they're doing. So all that said, it went really smoothly, right? Like everything just perfect. I wouldn't be here if it did, right? This would be the worst talk ever if it was just like, congrats, I'm done, walk off stage, have fun. So 3 stories about what we learned, because things were not always smooth. But we learned a lot in this, and we had some real good successes. As mentioned, Datadog is huge. Every day, we ingest over 10 trillion events. This is a lot. So we have a ton of stuff coming into Datadog. Metrics, events meaning logs or discrete events. Really everything that we run that's coming in. So performance is a massive priority for us. Part of our intake system uses Redis. For those who aren't familiar with Redis, key value store, very, very performant. Redis has an interesting performance model. I'll give you a moment to read this from the Redis documentation. So now that you've read this, right, imagine that you have Redis. You want to scale it up so that it handles 10 trillion events every day. How do you do that? Well, the answer is more Redis, right? Just rub more Redis on it. And this can be kind of challenging. What does that mean? Like, how do I run more Redis servers? Well, there's two ways, right? I could spin up a whole bunch of small EC2 nodes, like medium-sized instances. They have one vCPU, and just deploy like hundreds or thousands of Redis instances. And that's might be OK, but when you think about getting the best performance or like cost performance, it means that you're going to have a lot of nodes that are kind of sitting idle. And remember I said that we run Kubernetes. And so one of the great things that Kubernetes does is it abstracts away your real CPU into virtual CPUs. This means that you can actually pack a whole bunch of Redis containers onto one instance that has just one CPU. And you can really maximize that CPU usage, right? So that's what we did. We decided to pack a whole bunch of Redis containers into a pod. And we were using Envoy because we use Envoy for some of our basically networking, proxying, sort of pseudo service mesh. So Envoy, really cool feature that it can do is load balancing between all of these containers within a pod. And it does that by hashing. So the way that it works, for those who aren't familiar, ring hash algorithm, basically what it does is says, you're connecting to me. What I'm going to do is take your ID, and I'm going to hash that. And that will dictate which container within this pod I'm going to read data from and write data to. And that means that if you decide that you're going to connect as well, I hash where you're coming from, and that's different. And now every session or every connection that's made, I can know which pod or which container to write data to or read data from, and it can all be consistent, right? And so now we can have a whole bunch of Redis, and it doesn't matter where things get stored because Redis or Envoy is actually managing that in a load balancing. The problem with this, though, if you can imagine thousands, millions of connections, and you're running hashes, that becomes expensive on a CPU level, or it could be. So as mentioned, we decided to measure things. On the bottom here, we have x86. It's running Envoy 116. This was our baseline. So we are running 116 in production on our x86 services. We can see here the CPU per request. And then we decided to try that migration. And so the latest Envoy at the time was 119. It actually had a bunch of ARM64 performance improvements. And it was twice as bad in terms of CPU per request. So not good. The two lines here are basically we started playing around with performance in terms of Envoy has a published binary. Like, well, that's run with GCC. Let's compile it with Clang, see if different compilers work. The second line was with link time optimization. So we were trying to tweak things to see how good we could get the performance. Unfortunately, wasn't that good. Envoy 120 came out. We tried that again with doing a bunch of optimizations. It got much better, but it's still about 50% slower. So all that to say, first lesson from our infrastructure was measure performance, right? Even though Envoy was like, we made this new release, there's a bunch of ARM64 performance improvements, it turns out for that hashing, for that load balancing, wasn't enough. So as you do your migration, you will need to constantly measure. ARM64, while there's a lot of performance promise, it's not a silver bullet. So lesson 2 from our build and deploy. Question to you all, what's a container? I want you to think about that. So a lot of times when people ask me what's a container, particularly my parents, they're like, I hear you do like container things. What does that mean? Like it's not Tupperware, Mom. It's actually like a thing for software. But a lot of people are like, well, it virtualizes things away, right? It's like it's like a VM but smaller is one of the explanations. Or it's C groups and namespaces and people talk about jails and there's security isolation, which is that's a decent explanation. After diving into what we've been doing with containers, I would like to say that containers are like ogres. Ogres are like onions. Onions are parfaits or things. It's all about layers. So a container, actually, if I were to give you a container image, this is kind of what it would look like inside, right? You've got a manifest, which is a big blob of JSON, and then you've got all these different layers that are just gzips. And each of those layers has a little bit of information on how to build this container image. And that is the interesting part for us. And then if you start to think about multi-architecture images, it really is just a manifest that points to the different architectures for those container images. So all of this begs the question then, in terms of our build and deploy plan, how do you actually build this, right? We've got a process. We're using x86. That's pretty straightforward. We use GitLab. So it looks like a fairly standard CI/CD process of packaging everything up, running the process using Docker build kit or buildx to build our container images. What does that actually look like, though, when you start to think of, well, I now need to build on a brand new architecture? So the first thing that we thought was, well, we have a bunch of x86 nodes. Let's just use emulation. So there's a thing called QEMU. Basically, everybody related to the project pronounces it differently. But it's QEMU or Q emulation, something like that. This is basically what happens if you're running an M1 Mac. You are on an ARM64 processor. And so if you tell it to build an x86 image, what does it do? It does emulation. If you're on a Dell x86 machine, you tell it to build ARM64 and you're in Docker Desktop, it uses QEMU. So we're like, cool, it's out of the box. Like, this is the standard way that we do things. Let's just try that emulation. So let's do some tests, right? Because we've now learned that we need to measure everything. So we tried with a basic Hello World app, right? 23 seconds to build that container image. What does it look like on emulation? So we ran it, 64 seconds on average. Yeah, that's not great, right? It's like 2.5 times slower, but that's not bad. It's 64 seconds, a little bit over a minute. Not a huge slowdown in terms of developer efficiency. Let's try that with something in the real world. So we have a toolbox image that provides a lot of tools and frameworks that our developers can actually take use of, and we use this for a lot of our services. Normally, that runs in about 16 minutes. So again, we're thinking, well, 2.5 times, or maybe like 45 minutes. That's not great, but let's actually run this, and oh my God, 1.5 hours. So emulation, not a viable option here. You might have different experiences, but generally, I would say emulation is not the way to build your multi-arc images. So how do we build multi-arc images? Well, it turns out that we actually need to run ARM64 instances to build those images. In that case, you take advantage of ARM, and things actually build pretty quickly. So we started building things, and this is kind of what our Docker image looks like. It's pretty simple for this case. We're pulling from the Golang base image. We then check out some code from GitHub. We roll that to whatever hash or tag that we want, and then we tell Go to build it, right? Pretty straightforward. So we'd rolled out this multi-arc image builder with all of these workers, and ended up encountering this. This is the error that actually started occurring. So for those who can't really read this, because it might be a little small, basically what Go is saying is, hey, you had some functions defined in this file, and then they're getting redeclared in another file. And particularly in Go, you can't do that. You can't define a function twice. Now, some languages will let you do that, and they'll overwrite the previous one. Go obviously is compiled. It just says, like, I don't know what to do, so I'm going to end here. And we thought this was really strange. So let's walk through this as it's building. Because remember, container images are layers. So we'll start actually outputting the directory contents for each of these layers. So we run that git clone, and we run ls to see what's in that directory. And we can see that by default, this repo has two files, the readme file and a read.go file. That's pretty much what we expect. We run the next command, which builds our next layer, and that checks out the hash for the commit that we want, and then runs that same thing, and we can see that now that Git repo has been updated. So there's no more readme, there's no more read.go, there's now a consistent read.go file. Perfect. This is what we expect, this is what we want. So let's insert a new step, have it build another layer, and we'll just output what's in there. And surprise, everything's in there. Now, if you've run Docker before, if you've built container images, this is strange. This is not the way that things normally work. So it made us dive into, like, how does this actually happen? Like, as it's building layers, how does Docker actually understand what's in your file system? One of the interesting things is it uses a system called overlayFS. So overlayFS uses the whole native layers idea. So what it does is if you had that container image and you said from Ubuntu as your base image, what it would do is it goes out and grabs that. And that's what overlayFS calls your lower layer. So all of the files there, in this example, I've got 3 files, right? File 1, file 3, file 4. I run that next command in my Docker file, so I'm going to run that git clone. And let's say that git clone adds a new file, adds file 2, and it deletes file 3. Well, overlayFS then is a union file system, so it's going to combine this. And our final layer output is going to be file 1, file 2. File 3 was deleted, so that's gone. And then we have file 4. And then the cool thing is it takes layer 1. We move that to the bottom, so it's got those 3 files. We then run the next command. It does file additions or deletions, and that's combined for your next layer. So the question for you then is, if I have a directory, what happens for directories? Right? Give that a ponder. You've heard what happened with us with those 3 files, or all the files appearing. So if you think about our situation, this is basically what happened, right? Regular files come through, and then that directory that we had was somehow merged. But again, this isn't the way that Docker normally runs for images. If you've ever done Docker, again, on your desktop, you know that that directory should be replaced. So what actually happens in Docker is it uses a thing called trusted.overlay.opaque. It's an extended file attribute. And basically what it does is for directories, rather than saying delete all of these files and having to make a marker for each of those files, just says for this entire directory, overwrite the entire thing, right? Consider it as a file, as one big opaque thing. So it should work something more like this. And this is probably what you're familiar with if you're building Docker images, right? It replaces that entire directory. So we thought, well, let's take a look. Let's actually run this. So we ran it, and then we go to check that extended file attribute for overlay opaque, and it's not there. Well, this is weird. Why is it not there? Is there a bug in Docker related to ARM? So we started digging some more. Remember when I said that Datadog is also a security company? One of the interesting things about taking security as a high priority is our build system. If your build system gets hacked, that is a huge vulnerability. So one of the things that we decided to do as we were adding ARM64 builders was we'd built the system with basically rootless workers. This means that all of those instances that get rolled out don't have root access, because if anyone were to compromise them, it means that they now have a foothold. So they're ephemeral. They spin up, they don't have root access, they build the image, and then they get deleted. Turns out, trusted. Oh, trusted. If we don't have elevated privileges, we actually can't read this, and that's why it shows up empty. So then we got thinking, well, if we can't read this, there's got to be a problem. So we did some digging. We actually filed an issue on the buildx repo. We were like, hey, this trusted thing can't be read when Docker's running in user space. How do we fix this? It turns out that there was actually an update to the Linux kernel in version 5.11 that addresses this. So they actually added a user level extended attribute, so user.overlay.opaque. So that leads me to lesson number 2, stay up to date. As you're thinking of migrating, after you migrate, you need to stay up to date with all of your software. Everything from, again, Linux kernel, all the way up to the languages that you're using, all of your dependencies. We have found so much that gets updated constantly, that is constantly adding ARM64 improvements for performance, for security, or for just general functionality. So it's highly important that you stay up to date on all your software as you're doing this. So let's talk about our third lesson. One of the things that Datadog did when we first were founded over a decade ago was we forked statsd, and we created a new protocol called dogstatsd. Dogstatsd was an extension, so it added a bunch of stuff, including tagging, which is kind of crazy when you think about it now, right? We're so used to adding tags to metrics, tags in AWS for all of our EC2 instances, so we know like what they're running and where they're at. It seems crazy that this was like an innovation at the time, but it was. And it allows folks to be able to filter things down, right? You can see what's going on. As part of this tagging thing, though, when we're ingesting all of those tags, we need to normalize them, right? We need to actually have those tags come together so that you can properly aggregate and filter your metrics. So we did that. We migrated over our metrics intake system, and we started to notice some performance issues. So we dug in with our continuous profiler tool, and we were able to narrow things down to the runlen function within the UTF-8 Go library. Turns out that it was pretty slow. So a little over twice as slow on ARM64 is what we found. Again, this is kind of one of those weird things, right? Like we saw a performance issue with Envoy. What does this mean? Do we need to roll back? So let's dig in a little bit more. This is actually that runlen function from the UTF-8 library. It's pretty simple, right? I was surprised when we encountered this because I thought it'd be some complex amount of code that was really expensive, very CPU intensive. So the question then is like, why does this run so slow in ARM64? It's just a really simple switch statement. So we called up the Graviton team, and we're like, hey, help us out. Help us understand some of this. We're still digging into this. There's no clear answer. Currently, our biggest hunch is that this is branch prediction. So the way that modern CPUs work basically is as a switch statement like this comes in, it either needs to wait to figure out what the value of R is in this case, and then load up the instructions for that, which means it's sitting around doing nothing. Or modern processors try to intelligently just guess. And they say, based on past decisions in this branching, or based on what's loaded, it will actually try to predict what's going to come next. And again, currently hasn't been confirmed. We're still digging into it. It looks like that's a problem for ARM64 for this particular function. All that to say, fixing that, not an easy problem, right? Because number one, this is an open source library, so going about changing it and restructuring it. Also, how do you restructure this to be more efficient on ARM? It gets really crazy really quickly. So the interesting thing, though, is one of our engineers, Felix, was taking a look at this, and he was the one that found the issue in our profiler. And he was like, as we normalize tags, how many of those tags actually need to be normalized, right? Like, who's putting emojis in their tags, like on metrics? Probably no one. I hope none of you are. Most of them are just straight up ASCII. So what if we just skip this altogether? So Felix actually did the casework. He looked at all the metrics, found that 90% didn't need normalization. Of the ones that did, a vast amount of them were just ASCII, so didn't even need complex normalization. So he decided to write this really simple function, right? If it's already normalized when it came in, just return the tag. Don't do anything, which is crazy, because this alone, this simple change, completely removes any concern about ARM64 and that slowdown in that one function. This change alone lowered the CPU use on the normalization or the metrics intake by 5%, which is equivalent to hundreds of thousands of dollars every year in compute costs. So this was a major win. It leads me to lesson number 3 for you, which is rethink your code. Right? As you're doing ARM64, you will encounter errors, and some of them will be crazy challenging. And you need to, rather than dive in deeper, take a step back, think about what you're actually doing and the larger problem that you're trying to solve, and rethink your code. A lot of what you find as you're measuring your performance, if you can improve that performance, if you can find those hotspots, it'll just continue to compound the savings and the benefits that you get from ARM64. So just to recap those 3 lessons for you. Number 1, measure your performance. Measure everything, right? You really need to understand and keep in mind that your goal isn't migrating to ARM64. Your goal is price performance, getting better performance for a lower price. And if you're not getting that, then it's not worth migrating, and you need a measure to understand that. The second lesson to keep in mind, again, is to stay up to date. Things are constantly changing. That's why we have jobs, right? It's why you can't just deploy code and assume that it's going to run forever and be great forever. Things always get updated. Things always change, including instances, right? This morning, Adam announced the C7GN. One of the issues when we were making that list of services that we wanted to port over is we found a bunch of services that were like, there's no equivalent, right? We require high network usage. And at that time, the C7G would only go up to, I think, 50 megabits on the network. Now there's a new instance. It means that, again, now we can reevaluate what we're going to migrate. But you need to stay up to date on all of the announcements, on all the software changes. So C7GN, we're looking forward to that. And then, again, that final lesson, rethink your code. There's a lot of stuff that's going to happen as you migrate. You're going to have to not only think about how do I move this over, but start really thinking about that performance, about what can you change about your code to get even better performance out of that ARM64. All that said, I want to thank a ton of folks. I didn't do any of this work. It was done by all of these fine folks. Tommy Dyer, in particular, was our technical PM that led the project. We had a bunch of folks here. Also wanted to shout out to Ali and the Graviton team. They were a huge help. As mentioned, chat with Amazon. They would love to help you out. And nothing's better than like when you have an instance to be like, oh, hey, I can talk with the folks that actually made Graviton, that designed the processor, that understand everything about it. So shout out to everybody that worked on this. All that said, a few other resources. So my colleagues, Laurent and Eric, gave a talk about building container images. That was at KubeCon a couple months ago. That video is online, so the link is there. We also did a Twitch stream with the Graviton folks in which my colleague JP talked a little bit more about those layers and some of this new stuff we're doing with that. Particularly, we no longer build full images. When a developer updates their application, we are now going in and just hacking the layer that that application is at, and it saves us a bunch of time. So check out that Twitch stream. He's got a little more details on that. With that, there's a mic in the middle, so we can start doing a few questions, because I think we've got some time. As mentioned, my contact info was up earlier. I will flip over to the next slide. If you have questions about general Datadog and stuff like that, I'd advise you to go to our booth. You can't miss it. It's the giant purple one in the sponsor hall. But folks over there can answer far more detailed questions, especially if you have billing questions, because that is not me. That said, thanks for coming. Remember to fill out the survey, and my contact info, again, is on there in case you want to reach out later with questions.